Fashion Tech Alliance involves higher educational institutions, small, medium and big enterprises and a research center. This project has been co-founded by the Erasmus Plus program of the European Union and is aimed to facilitate knowledge exchange between partners and to design and pilot learning experiences to engage students in a fashion tech residency program, embedding young talents in the company's innovation activities. A central objective of the project is to design multidisciplinary, interdisciplinary and intersectoral learning activities involving international students from 5 European universities. The contents of the lectures have been specifically created to match the needs of fashion tech learning. They have become open educational resources to allow future engagement between a European-wide fashion and textile HEI community and are available under Creative Commons Sharealike 4.0 with the aim of a wide and free distribution, access, use and reuse. Ready to learn more about fashion tech? Enjoy the lecture!
Good morning, I am Marina Carulli from the Mechanical Engineering Department of Politecnico di Milano. In this lecture, I will present an introduction about 3D modeling and virtual prototyping of garments. Specifically, we will see in which way it is possible to integrate these innovative tools in order to optimize and improve the design process of fashion products. In particular, the most important topics that we will see together in this lecture will be the design process in the fashion sector, the innovation of the design process in the fashion sector, 3D modeling and virtual prototyping of clothes, commercial software for the 3D modeling and the virtual prototyping of clothes, and the Cloth 3D software. As first step of this lecture, we will see together a brief overview of the traditional design process in the fashion sector. Then we will move to analyze the role of the prototyping activity in the design process. There are several models to describe the design process in the fashion sector. In general, we can say that the main steps of the design process in the fashion sector can be organized as following. As first step, we have the materials and fabric selection. Then we move to the design step. Then we have the patterns making and the prototype making process. Then we move to the prototype review and to the approval of the final design solution. Finally, we have the pattern grading and manufacturing steps, and then the retail. The just presented steps can be also visualized by using a graphical representation of the design process in the fashion sector. Specifically, here we have as first step the material selections, in which, as example, we should select the fabrics that we will use for our final collection. Then we will move to the conceptual design step and consequently to the pattern making step, in which we will create all the patterns of our garments. On the basis of those patterns, we can then move to the creation of our prototype. The prototype is a central element of our process. Indeed, by using the prototype, it is possible to review our design ideas and check and refit our patterns. After this process, we can go to the approval of our collection and then to the pattern grading and manufacturing process of our garments. The last step, usually for companies, is the retail of our garments. As already introduced, the role of the prototype in the design process is very important. Indeed, by using the prototype, it is possible to carry out several actions. For example, we can observe the real performance of fabrics in each specific garment, and we also check the aesthetic features of fabrics. Also, by using the prototype, it is possible to check the fit of our garments on the standard tailor's dummy. By using the prototype, it is also possible to evaluate several features of our garments, such as the effect of application, zippers, buttons on our garments, but also any possible errors and suggest to the pattern maker the corrections. Finally, by using the prototype, it is also possible to observe the thicknesses that are created by the several elements of our garments, such as different fabrics, layers, seams, folds, applications, and so on. As last point, with the prototype, it is also possible to check if the desired effects is really possible and achievable with the selected fabrics. On the basis of the just presented design process, we can now move to analyze in which way ICT tools and more specifically 3D modeling and virtual prototyping techniques and software can innovate the presented process. As first point, it is important to say that in the last years, ICT technologies are already widely used in the fashion industry. In particular, they are used in the areas of product management, logistics, security, and certifications of products. So, for example, those ICT tools are used for online marketing and sales of certified products. On the contrary, in the design process of fashion products, ICT technologies have up to now had a limited impact. Indeed, in this case, some technologies are used for the digital translation of some phases that were previously performed by using physical tools. I am referring, as example, to the modeling, pattern making, pattern grading, and similar activities. However, in the last years, the global fashion market has been subjected to important changes. The evolution of this market requires now companies to launch new products in ever shorter times and with greater frequencies, usually by using web platforms, social media, and more general communication tools, and also, if possible, to give the consumer the opportunity to buy their products directly online. This is particularly important for low medium market segments with large scale diffusion. Indeed, in those market segments, the purchase doesn't represent a high investment for the final customer. In this case, and for this type of products, the customer is willing to buy without the need to touch and try the real products. In those cases, the only element that the final customer can evaluate is the aesthetic appearance of the products. For this reason, the visualization of those products must take place through realistic representations. On the basis of the just presented observations, it is possible to affirm that ICT technologies can be used to support the fashion product design process in order to make it more effective, integrated, flexible, and also in order to reduce time and cost. For example, those related to the prototyping activity. So, in order to do this, it is possible to affirm that the virtual prototype can represent a central element of the new design process, and it can be used from the conceptual phase to those phases of the online marketing and sales. The main advantage of this innovative design process based on ICT tools and more specifically 3D modeling and virtual prototyping of garments is the possibility to exploit the potential of those 3D virtual prototypes and the information that can be integrated into them. This is also very important for the fashion designers. Indeed, for the designers, this means that they have the possibility of obtaining a complete and realistic representation of their ideas, and also that they can communicate their ideas to others without possible errors of interpretation and misunderstanding. As example, this already occurs in the industrial design sector, in which 3D modeling and virtual prototyping are techniques widely used in the design process by designers and have already proven their effectiveness for the design, development, evaluation, testing, and communications of new design solutions. In addition, it is worth reporting that the innovation of the design process in the fashion sector can be obtained only through new professionals able to use ICT tools, and more specifically 3D modeling and virtual prototyping tools. Indeed, those new professionals should be able to use those tools to express their new creative ideas and make them concrete in realistic virtual prototypes. So, if we open again the graphical representation of the traditional design process in the fashion sector, we should focus on the role of the real prototype that we have at the center of our graphics. Indeed, this prototype has been made by using 2D patterns and can be added during the review step. On the contrary, in the graphical representation of the innovative design process in the fashion sector, the virtual prototype has a central role. First of all, it is created by using digital bidimensional patterns. Also, it can be used for the review phase of the design process and also for the patterns grading. After the review and the approval phases of the design process, it is also possible to create a final prototype of our garment in order to check the final details of our garment. Moreover, doing a step further, we can also represent the new design process in the fashion sector based on the use of ICT tools. In this case, the virtual design has a central role, and it substitutes the design and the prototype activities. So in this case, the virtual design can start from dimensional patterns that the company already has and can then now modify them in order to obtain new garments. Also in this case, it will be then possible to review the new design solutions and then also create the pattern grading. Then, after the review and the approval phases, also in this case, it is possible to create real prototypes before the manufacturing and the retail phases. We can now move to present the main features of those 3D modeling and virtual prototyping software and in which way it is possible to use them in order to create the virtual prototypes of our garments. In the fashion industry in the last years, the use and impact of virtual prototyping techniques is growing, and more companies are using software for the design and the development of virtual prototypes of garments. Indeed, the software for creating virtual prototypes represent a significant change in the design process of the fashion industry. More specifically, they can reduce the number of dimensional patterns that should be created and added. They can also impact on the cycles of the design process, and they can allow the definition of 2D patterns directly from the 3D garments. On the contrary, by using those tools, it is also possible to create in a very easy and fast way 3D virtual prototypes of garments starting from bidimensional patterns. After the design phase, it is then possible to modify those bidimensional patterns and 3D garments and also apply textures, apply finishing effects, and so on. It is now very important to give a definition of the 3D virtual prototypes of garments. Those 3D virtual prototypes are realistic representation of garments due to the fact that they are created by simulating the real behaviors of pieces of fabrics affected by different kind of cuts, seams, finishing effects, sewing lines, and also the use of trims, applications, buttons, button sole, and so on. So, by using those virtual prototypes, it is possible to verify the real behaviors of garments, the wearability, and also their aesthetic appearance. As regard the just presented definition of realistic virtual prototype of garment, it is important to highlight that it is possible to obtain this kind of result only by using the numerical simulation of fabrics, which are soft materials. So, on the market, we have several tools that we can use for obtaining this kind of results, but we also have other software that will produce only 3D models of garments and that can be used, for example, for producing garments for movies, video games, and so on. As already presented, the use of realistic virtual prototypes of garments can bring to the reduction of cost and times of the design process. Also, by using those virtual prototypes, it is possible to reduce the number of physical prototypes that usually are necessary for evaluating a collection with several garments. While in the past those softwares have been created and validated in the academic world, now we have several softwares on the market. So we will see now the most important commercial softwares for 3D modeling and virtual prototyping of garments and their main features. So, today on the market, we have several software for the 3D virtual prototyping of garments. The most important ones, according to their features and their distribution in the fashion industry, are Browser VStitcher, Lectramodaris 3D, Optitex 3D, and Claw 3D. The first software, named VStitcher, has been created by the Browser Software House. It is a 3D software for the design and the development of garments. By using VStitcher, it is possible to design garments through size ranges and also apply graphics, fabrics, trims, colorways, and other applications. And it is also possible to obtain photorealistic renders. Among the several possibilities that we have in VStitcher, it is, for example, possible to customize parametric avatars, which are virtual dummies on which we can design our garments. It is also possible to create layers with different fabrics and create and adjust colorways. Also, it is possible to use photorealistic materials in order to create real-time photorealistic renders. Then we can now move to the next software named Lectramodaris 3D. Lectramodaris is one of the most used dimensional pattern design software on the market. A peculiar feature of the Lectramodaris software is that the pattern design part is very functional and the obtained bidimensional patterns are fully adjustable both in the design and in the development phases. As regards the virtual prototyping of garments, Lectramodaris presents a 3D module for fit control, style validation, and collection review. However, in this case, the simulation of garments and of their features is not totally reliable and effective. The next software is named Optitex and has been created by the Optitex software house. Optitex is one of the most used software for the virtual prototyping of garments on the market, and it has a huge number of customers. Indeed, Optitex presents cutting-edge technical features and also an optimal integration with other software for the 2D pattern design. Optitex presents a wide range of processes to choose from. Among them, we have, as example, seams, zipper, buttons, holes, and many more options. In Optitex, the simulation is very precise and reliable. It is also possible to create soft objects with the same precision as garments. We are now moving to the last section of this lecture, which concerns the Claw 3D software and its main features. Claw 3D is one of the most used software on the market for the virtual prototyping of garments, and it has been created by the Claw Virtual Fashion Software House. In Claw 3D, we have the possibility to obtain real-time simulations of garments, fabrics, and other elements. Claw 3D can be used to optimize the fashion design process thanks to its reliable and precise simulations. Within Claw 3D, it is possible to design garments by using several direct modeling techniques. However, as for the other just presented software, in order to obtain reliable results, basic knowledge of pattern making and tailoring techniques is necessary. In Clo3D, we have a huge range of possibilities for creating and personalizing the virtual prototypes of garments. More specifically, by using Clo3D, it is possible to import bidimensional patterns created with other software, but also to create virtual prototypes of garments starting from the scratch in Clo3D. Also, it is possible to personalize the virtual humanoid avatar, so our virtual dummies, and arrange patterns on the avatar's body. Then, in Clo3D, it is also possible to create sewing lines among patterns and select different types of fabrics and materials. Finally, we can also create photorealistic renderings and fashion shows. Another product of the Clo virtual fashion software house is named Marvelous Designer. Also in this case, by using this software, it is possible to obtain virtual garment. However, also if the two software seems to be very similar, in the Marvelous Designer software, the garments and the fabric simulation is less precise and reliable. For this reason, Marvelous Designer is usually used for not professional uses.